Then Euler's theorem and distribution. So this is another topic, very important topic for the students of economics, and will come that it is a homogeneous function and it satisfies the conditions as x fx plus y fy is equal to h cube when h is the degree of homogeneity. So we will discuss in details later on. Now it is said that this is the marginal product with respect to x and multiplied by input. This is the marginal product with respect to y and multiplied by level of input y. So if we input and sum up, it is equal to the output multiplied by degrees of this degree of homogeneity, h in degree of homogeneity, when h is the degree of homogeneity. So degree of homogeneity multiplied by output is equal to this. So it is used to explain the marginal theory of distributions in economics. So we'll discuss. So hello viewers, we are discussing Euler's theory. Now we have stated the Euler's function as x fx plus y fy is equal to u. Now dividing both sides by the quantity, we will get omega 1 plus omega 2 is equal to k. Now what is omega? That is the elasticity. So I have given the elasticity. So if we divide by the quantity, we will get delta q by delta x1 into x1 by q. So earlier we got fx, fx1, x1. So if we divide by q, then it becomes the elasticity formula. Proportionate change in quantity produced by proportionate change of the input. So this sum of the elasticities will be equal to the homogeneity when degree of homogeneity is 1. So this is the character is that if the function is homogeneous of degree 1, then sum of the elasticity omega 1 plus omega 2 will be equal to 1. So this x1 f1 plus x2 f2 is equal to q. Now total output is equal to the mp of x1 multiplied by its quantity plus the mp of x2 multiplied by its quantity. The meaning is that the f1, it is the marginal product with respect to x1. So marginal product multiplied by the input plus a marginal product of the second input multiplied by the quantity of second input, it becomes equal to q. If the production function is homogeneous of degree 1, payment of each input, the value of the marginal product, total output will be exhausted. This means if we pay the value of the marginal product, then it will be exactly equal to the total output. That means total output will be exhausted. In other words, under the condition of constantly returns to scale, if each input factor is paid the amount of its marginal product, the total product will be exactly exhausted by the distributive share of all the inputs. So this is the other way of expressions. Now this relation may not exist in long run as well as under imperfect competition, even if the function is homogeneous of degree 1. So this is the limitation of the Euler's theorem, that even if the degree of homogeneity is 1, so this may not work under long-term situation and under imperfect competition. So sometimes it is asked in the UGC net and sometimes also in EPSC that what is the limitation of the Euler's theorem. That even if, in short, the answer is that even if the function, total production function is homogeneous of degree 1 under imperfect situation, so the function, that means the Euler's theorem, may not work under imperfect competition and in the long run. So in the long run and under imperfect competition, it may not work. The conventional analysis of profit maximization breaks down if the entrepreneur sells his output at a constant price and possesses a production function with homogeneous one. This is another one. So if the entrepreneur of the producer sells his output at constant price, then also it will not work. So three different points: constant price, selling at constant price, then imperfect competition, and long run. So under these three situations, the Euler's theorem may not work. So proof of relation of Euler's theorem. Now x delta q by delta, that means x fx plus y fy is equal to hq, that means function plus the degree of homogeneity. Let it be raised by t factors. Tx, ty is equal to t to the power h fxy. Okay. Let us start. So using the implicit differentiation, so we have discussed earlier what is implicit functions. So if we differentiate, then left hand side will be equal to delta f tx ty. So this is the function, derivation of the function with respect to x after raising to t times, and delta tx by delta t. Okay, so tx will be cancelled. Ultimately, is a function with respect to the t times plus delta f tx ty, delta ty by delta ty into delta t. So it is into delta t. So this is x ftx plus y fty. Ultimately, what is this? This is x ftx plus y fty. Now right hand side, delta t to the power h by delta t, function into function fxy, because it is the multiplicative rules, t to the power h into delta f xy by delta t. So this gives h t to the power h minus 1 into f xy plus 0, because this part, the value of this part will be 0, because it is delta t, but there is no delta t. So h t to the power h minus 1 into the function. Since left hand side is equal to right hand side, so x ftx plus y fty is equal to h t to the power h minus 1 and f xy. Now if t is equal to 1, suppose homogeneity is 1, then x fx plus y fy is equal to h times fxy. So h is the degree of the equations. If the function is linearly homogeneous, then h is equal to 1. So in that case, x fx plus y fy is equal to fxy is equal to q, because h is 1 multiplied by 1. Now example, suppose fxy is equal to x square minus 3y square. It is a homogeneous function of degree 2. Euler's theorem, if we apply Euler's theorem, x fx plus y fy is equal to, what will be 2 times x square minus 3y square, because fx is equal to 2, fy is equal to 6y. It is 6y minus 6y is 6y. So left hand side is equal to 2x square minus 6y square is equal to 2 times x square minus 3y square is equal to right hand side. So left hand side is equal to right hand side. Proof. Now there is a small exercise. If p is equal to this, so it is a CD function. If p is equal to this, which is a function of labor and capital, so LFL plus CFC is equal to P, so that left hand side is equal to right hand side. So just find out the partial derivative with respect to L and C and multiply, then sum up, you'll find that left hand side is equal to right hand side, like the earlier example. So with this, we will complete the Euler's theorem, and for homework you can go through more problems, examples for solution. This will be good exercise. Thank you very much for watching. Keep on watching, and please share and subscribe. Okay, thank you. See you.